Hey folks, RiverMan here. I'm going to make my own little video on how to do a BGA reball. This is a DV6000 motherboard. It had the classic GPU symptoms where the computer will boot but nothing shows up on the screen. So I'm going to reball this chip right here. And I've already got my jig in place. So let me just put the board down. Okay, you'll notice over here the bottom nozzle is right up to the bottom of the board. I got my thumb drive, my worm screw, where it almost touches the bottom of the board. Now, this is the chip here. I'm going to choose a nozzle that's slightly larger than the chip itself. So let's go with this one, and I'm going to put the nozzle down about 5 millimeters from the actual chip. Now here's my profile. So now we're going to see these numbers. Okay, here's my profile for, this is the lift, and it's also the same profile for lead-free reflows. You can write this down, pause the video and write these down if you'd like. Okay, here's the one, here's for the bottom heater. Actually, people can read those numbers. Okay, there's the upper and lower profile. I've got my preheating temperature set to 200 degrees. The upper breath is set to 7. And everything else is in neutral. And basically we just hit run show. Alright, we're getting close to the end of stage 5. Here in just a second I'll start checking to see if the chip is loose yet. Okay, now we're on to chip stage 6. Now I'll check to see if the chip is loose. No, it's not. Okay, I'm going to pause. I'm going to pause these two profiles until this chip is loose enough to pull off. And we'll poke it with a toothpick every so often to see if it's loose yet. Getting there, almost. Okay, just another second or two and this should be ready to come off. Okay. I'll go ahead and turn the machine off. We'll let this chip cool a little bit. Okay, now I'm going to set the machine up so it heats the board to 150 so I can clean the solder pads. And I've got this set up on profile PTN 1, and here's the top, the ramp at 150 degrees, and I've got it set for 180 seconds, but I pause it until I'm done and just manually force the machine off. Here's the bottom, 160 for 180. And we'll go ahead and start it. I still got this at 200, still at 7. So as soon as these reach 150, 160, I'll go ahead and pause it and we'll start cleaning the pads off. Okay, we've reached board temp of about 150 degrees Celsius. So let me move the top nozzle out of the way. We'll put some flux right here. And then use my soldering iron. I've got to melt some leaded solder. Until I get a ball going. Then basically we just move this ball around and pick up as much of the excess solder as you can off this board. Try not to leave the ball in any one place for too long. Okay, then we come behind that with a wick. Now this wick, you just barely float it across the pads, just enough to flatten out the solder. It's another thing, you don't want to leave too long in one spot. And you also have to be careful with all these little chips, these little resistors and capacitors and whatever that are right next to where the BGA came off of. But you just barely float this around. Okay. I'll take a Q-tip and start cleaning up some of this old nasty flux. And I'll take a Q-tip and dip it in a little alcohol, little IPA, isopropyl alcohol, and we'll rub it around, try to clean up as much of this nasty stuff as I can. Okay, now on to the chip. Okay, here's the NVIDIA chip. This is a NFG6150-N-A2. There's what the bottom side looks like. Anyway, we're going to clean all this stuff off this bottom of this chip. So basically this is the same procedure as I did on the motherboard itself. Take a toothpick and spread a little bit of flux on it. Then I'll melt some low melt solder. And we'll drag it around. I'm trying my best to keep the iron from actually touching the chip itself. I just want to drag the ball of solder around. Pick up as much of that old solder as you can. And then we use the wick again. This is obviously another place that you don't want to leave the iron in one spot for too long. And you definitely don't want to press down very hard. We're not trying to sand the solder balls off. You just need to melt them off and draw them up into this copper wick. I want to try to get this as smooth as possible so the balls don't roll off the top of a mound of solder that I might have left on there. Okay. And we use the cotton swabs again to take as much of the old nasty flux off. And this is just 91% isopropyl alcohol from the pharmacy. Can't seem to find actual IPA here, 100%. Get this as clean as possible. Okay, here's the stencil I'm going to use, NFG6150N-A2, and you can look at the chip and tell the pads match up with the holes on this. So anyway, here's how we put it in our jig. And when I crank these screws down, I don't crank them down all the way until they're tight. I just put them on there loosely because you're going to have to adjust this stencil to match up to the pads on the chip itself. So tighten them all the way down and then back off a little bit. Now we'll set it on here and see if you can look down in there. I don't know if you can see this on the camera, but you can see through the holes to the pads below. You got to move the stencil around until you match up, until all the until you see a pad through every hole. Okay, now I've got my my stencil set up where it lines up. I don't know if you can see that, but there's a pad under every hole. So anyway, this is Amtech 559 flux, and it doesn't take much, about that much for that whole chip. I'll just smear it with my finger. Make sure you cover the entire chip. Every pad needs flux. Now we'll put the stencil on, and these are 0.6 millimeter balls. Just pour some in there. Shake it to make sure we get a ball in every hole. And I'll pour off the excess. And with any luck, I'll lift this. And ta-da! Got a ball on every pad. Okay, so now a lot of BGA guys don't like the fact that I use a heat gun to set these balls, but I find it a lot easier than putting it back on my machine. So let me check it first to make sure there's no balls stacked on top of each other. Okay, it looks good. Also need to inspect to make sure there's no balls that will potentially bridge when I heat this. Okay, that looks good. So now my my hot air wand I have set to 480 degrees. Now I'm going to start off up here. I'm going to start off about this far away just to heat the chip up slowly. You don't want to come in too hard and heavy. And I am blasting 480 degrees Celsius out of this thing. So we just keep rotating it, waving it around, and try to get the heat as even as possible. Once the balls start melting, try to get as close as you can so you can actually see the balls melting. Okay, and I'm bringing this in closer and closer now. You should start to see the balls melt and stick to their pads. Okay, now they're starting to stick to the pads. You got to keep moving this wand. Don't want to leave it in one spot too long and fry this chip. Okay, well, that looks good enough. Looks like the balls are melted to the chip pretty well. I don't want to push my luck and heat this and overheat it, so I'll stop right there. We'll let this cool down for just a second. Now back over here on the machine, I'm going to put a little more flux over here than I had on the chip itself. But not much more. And I'll smear that around with my finger. Make sure to get flux on every pad. Pads all over that. Okay, now here's the chip with balls. So now I'm going to position it. If you look, this chip is dirty, but there's a little brass arrow on that one corner. You match that up to the marker on the board itself, and we'll try to get this chip as centered in the white outline, centered as possible. Okay, now we basically just run another profile. Okay, here's my numbers for the chip attached profile. I've got this saved in PTN2 on both of them, and here's the numbers. Ramp of 2, 140 degrees for 120 seconds, etc., etc. Okay, there's the upper, here's the lower. Okay, so I've still got everything else set just like it was, so we'll go ahead and run this, and this will attach the chip to the motherboard.